Yo, what's up, guys? Welcome back. Episode 73, I think. 73. No, 74. Wait, is it 74, man? I don't even know. Maybe it's 74 today. Is it? 73 yesterday. Yep, 74 today. Pokemon 74. Welcome back, episode 74. We're going to get straight into it today. Check out our Pokemon sound of the day, which is Geodude. A classic Pokemon. Let's take a look at the sound, shall we? We got an ad, though.
Freight for affordability. What you might not know is performance and durability go right.
I feel like a lot of the Pokemon sounds all sound the same. Like, maybe they cry or their sound is different. I don't know. But I love this cry. It's so nostalgic for me. Same with me, bro. That's our Geodude right there. Look at this guy, bro. Nice. Second we got a problem of the day. Oh man, it's cold here, bro. Jeez. What do we got today? Find all possible recipes from given supplies. Take a look. Given information about n different recipes, you're given string array recipes and a 2D string array ingredients. Yeah, the recipe has a name, recipes I, and you can create it if you have all the needed ingredients from ingredients I. A recipe can also be an ingredient for other recipes, i.e. ingredients I may contain a string that is in recipes. If you're given a string supplies containing all the ingredients that you initially have, and you have an infinite supply of all of them, return a list of all the recipes that you can create. You may return the answer in any order. Okay. So we're given 3 arrays of recipes and ingredients and a supplies. In this case, we got our recipes bread. We have ingredients, yeast and flour. We have our supplies, yeast, flour, and corn. We can create bread since we have the ingredients, yeast, and flour. Okay. I feel like this problem isn't too bad. Like, I mean, kind of understand a little bit. Bread, sandwich, burger. We got ingredients, yeast, flour, bread, meat for the... So... Okay, the bread is yeast flour, the sandwich is bread meat, the burger is sandwich meat bread. Supplies, this is what we have. Okay. Oh, okay. So we can make bread, yeast and flour. We create bread since we have the ingredient meat and can create the ingredient bread. We can create burger since we have the ingredient meat and can create the ingredients bread and sandwich. Okay. Recipes I, ingredients I, J, and supplies K consist of only English characters. Okay, so the values of recipes and supplies combined are unique. Each ingredient I does not contain any duplicate values. Okay. Trying to think. So the way I come thinking about approaching this problem is that maybe we can loop through our recipes, right? We keep our supplies variable, right? Okay, well, obviously we want to loop through our recipes, right? Because we're trying to create everything that we can. We have to check, well, what ingredients we have and the ingredients it needs and the supplies we have. All right, so we're going to have to somehow keep track of our supplies array because we can make things out of that. So really we're kind of looking through the ingredients and the recipes. Okay. I thought it was a hash table. It's kind of what I was thinking a little bit. Can we use data structure to quickly query whether we have a certain ingredient? Once we verify that we make a recipe, we can add it to our ingredient data structure. We can then check if we can make more recipes as a result of this. Okay, that's what I was kind of thinking. We're going to have to somehow keep track of this, right? So I'm going to declare a dictionary. Okay. I'm also going to loop for I in range. For I in recipes. My dad's calling me. Okay, we can pass in our recipes. Sorry, we go. Recipes, right? Let's call this. Sorry, my fine recipes. We have to check, well, Y supplies. Let's print my supplies because I kind of want to see what it looks like here. Okay, let's get rid of this. Okay. Oh, sorry. Oh. Okay, maybe is equal to counter supplies. Would this work? Counter yeast, flour, corn. Okay, right. So create a hash map. Okay, we'll do that. We'll use a counter. All right. I think we can loop through recipes, right? Add recipes as a key. and then the ingredients as a value. Is that possible? But I don't know, like in a what is going on out here? Okay, so it can be a list of strings. Okay, so maybe we can make this a simple, instead of a counter, we can make this a simple hashy, right? Just make this a set, right? Sorry, we can keep that. Make this a set. Sorry. Let's call this my supplies. Okay, all right. So these are our supplies, and then we can create, we can go, well, for I in recipes, and then we can do, well, if I not in my dictionary, we can add it. So my dictionary, I Okay, this is an interesting way to do this in Python. You can use a zip function, which I didn't even think was a thing, but all right, let's do receipt dictionary. We use list comprehension where we go dictionary comprehension where we go recipes I, ingredients I for I in range length recipes. Let's print our recipe underscore dictionary. Nice. Okay, that worked. Okay, so now we got our dictionary for fast lookup, so we can look at what the ingredients we need, and then we just check inside of our my supplies if we have these ingredients, right? So we can loop through, well, we do for I in okay, so for key value in recipe underscore dictionary dot items, we can check, well, if key value. See, I'm so used to the value just being an integer that I've never really worked with like a hash map with a value that's not an integer. So let's see. If set value is subset, I didn't know you could do this, of my supplies, right? If it is, then we can add the key. We can do key dot my supplies dot add. We add the key, right? And then we can have some sort of res array here. A res array, right? We can check, well, res.append key. We can append the key each time. And then we can just return our res. Let's see if this passes. There we go. Oh, damn. Bro, what are these supplies, bro? Like, what sort of test case is this, bro? Like, this is insane. Like, and is equal to recipes.length is equal to ingredients.length. Your for loop checks each recipe once, but recipes that depend on other recipes might not be craftable in the first pass. Wow, use a graph here and a queue. Current pros using topological sorting Khan's algorithm. Using adjacency. Jeez, I didn't know this code was that. Your for loop checks each recipe once. The recipes that depend on other recipes might not be able to be craftable on the first pass. Does not reprocess recipes. Some recipes might initially be missing ingredients. Okay. Correct approach using topological sort. Okay, we do this, yeah. We make a graph for an empty variable for recipe and recipes in degree. Build the graph dependencies. Wow. That's kind of impressive that was this much to it. Like, cooking recipe with DFS and BFS. Oh. Okay, he does the same thing as me. He creates a hash map, right? Update is equal to true. Well, updated. Update is equal to false for R and recipes. If R is available, if R is available, we cooking. Available.add R update is equal to true. Get that DFS Giga Brain strat. Let's talk about the OG way, brute force BFS vibes. No thinking, no optimizing, just a monkey brain checking every single recipe one by one until we figure out what's cookable. A true skippity approach. DFS problem? Ain't even a problem. Oh, yeah, we got some recipes. We're gonna stick with the BFS problem here. Kind of want to think about this problem. Okay, so we do the same thing. So we have a my supplies. Okay, we don't need this reservoir. We have supplies, right? We have a recipes dictionary that does the same thing. We do recipes I. Is it recipes and ingredients? I think it's the same thing, to be honest. Print recipe underscore dic. What do we print? Bread, yeast, flour. Okay, like a list type. Okay, what do we print here? This is his. I'm curious to see what. I think it's the same thing. Like, because we looked at the zip function for a little bit. Okay, it's a hashy inside of a hashy. Right. I'm gonna slip into we ain't cooking no more. This guy's funny. Curious, what time's Illinois played? I don't have time. Does Illinois 8:45? Okay. Okay. Will this work? I'm curious. Hash pool type. Set I for recipes, ingredients in zip, recipes, ingredients. Okay. All right. So we can check. Well, okay. So we create a updated is equal to true. Okay. While updated. So while updated is true, we want to set updated is equal to false. And we want to do for R in recipes, right? So for each value in recipes, so we got bread. If R in available, then we can skip this one because we already made it. Then if needs, sorry, it's meant to be recipe underscore dic R is dot is subset of available of my supplies comes by now. Okay, so I think we're checking the set. Okay. Then my supplies dot add updated updated is equal to true. Okay, well, the while loop keeps us iterating from the beginning. But I'm curious, what does, let's print recipe underscore dic in my supplies, that's what it's meant to be. Getting a call. 1 second. I'll be back in a second. I'm just gonna answer this call. Okay, I'm back. I think there's something wrong with this. There we go. Okay. All right, we're back. All right, let's take a look at this. So, how R is our bread, right? Obviously, because we're looping through the recipes, right? Then our recipe dictionary R, because we're getting the value. Okay, that's the value. We're checking the value of that is a subset of my supplies. All right, and then we do my supplies.add. R, if it is a subset, we add R. And then we say updated is equal to true. Right? Okay, we change the flag here because this could be our last value. All right. Okay. Interesting. I believe this should work. What we can do is we can just return what are we returning? We would return my supplies, right? Now we need to do we cast it into a list? Not the wrong answer. I'll put yeast bread, corn flour. We only want to return bread, so we got to loop through this. We got to loop through for R in okay, so obviously, like, my thought process is that we need to loop over this. We need to check, well, if R, the value that we're checking, was not in the original supplies, then we just return that value. So R for R. How do we do that in recipes? If R not in R for R in recipes, right? So we're looking at this one here, the recipes, which is bread. In my supplies. Whoops. There we go. Hopefully this submits. Too slow. Jesus, too slow. Is it too slow? Do we have to solve it? Like, bro, this is insane. Like, this is hard. I don't really know what topological sorting is. What is that? Well, I just want to use a linear ordering of vertices in a directed acyclic graph where each vertex appears for its adjacent. Okay, I think I have learned of this actually. It's ringing a bell. Yeah, bro. This is definitely a very, very tough problem, bro. Like, very, very tough. Yeah, I feel like I'm going to need more knowledge to solve this problem. So we're going to call it on this one. I just don't really understand the topological sorting. I feel like that probably is going to come once we get to doing some graph problems. So, you know, I'm just going to go back. I'm going to pick a problem from here, do one more problem, and then call it, because my buddy's here. So, yeah, let's finish this one. This one done. Consider right now, I return a list answer of size 2, where answer 0 is a list of all distinct integers in nums 1 which are not present in nums 2. Answer 0 is a list of all distinct integers in nums 1 which are not present in nums 2. Answer 1 is a list of all distinct integers in nums 1 which are not present in nums 2. Note the integers in the list may be returned in any order. Okay. Return a list answer. Okay, so we're gonna have to, I think we have to specifically call it answer. The list, so we do, well, I in nums. Yes, we can create like two arrays, co1, co2. Alright, so do for I in nums if I not in, and then we can co1. Let's print out co1. Nums1. Jeez, man, I'm getting bad syntax everywhere, bro. Okay. Then we just append answer.append co1 for I in nums2 if I not in nums1 co2.append I. Then we just do answer.append co2, and we just return answer. Will that solve this problem? Three. Why is it not appending duplicates? Why not in? I don't know why it's not appending duplicates right now. That's so weird. Why is this not appending duplicates? 3. I don't see any reason why this shouldn't be appending duplicates. Why is this not adding duplicates? I mean, we have a list. Not in runs in O of n for each I, making sure the overall decision. We want duplicates, dude. That's the issue. I don't know. Let's try and add it differently. If I in nums2, we want to just continue. We want to else. Do the opposite. Still the same. When do we do this? September 13th, 2024. How can I not do this, dude? I really don't get why it's not. Doesn't show uniqueness in the input. Oh, wait, hang on. Oh my god, I was getting confused. Oh my god, dude. I was getting confused. I thought this was the expected, and it was like it wasn't counting the duplicate in the array. Like it was like, and I was like, what? We're trying to find unique values. Okay. Right, so we're trying to find unique values, then we simply just, turn this into a set. Set nums1, set nums2, right? For I nums1, we want to create, like, let's say, unique nums1. Unique nums2, right? For I in nums by in unique nums1 in unique nums2. Damn, bro, I didn't mean to do that. Like, okay, there you go. Now it submits. Interesting. What's the fastest solution? Oh, okay. Yeah. Cool. We're nearly done with these problems. Longest subarray of ones after deleting ones. Check out this one. Given a binary array nums, you should delete one element from it. Return the size of the longest non-empty subarray containing only ones, and the resulting array returns 0 if there's no such array. Given a binary array nums, you should delete one element from it. Return the size of the longest non-empty subarray containing only ones in the resulting array. Okay. This is easily a sliding window problem. Dynamic programming. Ranged length nums. Okay, we want to check, well, okay, let's see. Count zeros is equal to 0. Right? If nums I is equal to 0, we do count zeros plus equal to 1. Okay, then we do while We need to create a left pointer. Alright. For right in range, we have a right here is equal to 0. All nums right is equal to 0. For right in range like nums, if numbers right is equal to 0, count 0 is plus equal to 1. All nums right. Okay, well, if count zeros is greater than 1, we're at the next value. So we want to make left is equal to 0. Left is equal to right. This is greater than 1. We'll make left is equal to right. We do a max right. So we need a res result because we're returning an integer equal to 0. We would do, well, res is equal to the max of right minus left plus 1. So actually we want to do res and right minus left plus 1. Right minus left plus 1. Return res. What went off, dude? Why are we one off? Alright, then we do need to do left minus equal to 1. Sorry, no, count zeros. Minus equal 1. Okay, right now we have a group of values. We have 1, 1. No, we need something with more. 0, 1, 1, 1. 0, 1. 1, 0, 1. Okay. We check, well, if we have a 0, we increment 0, right? So count 0 is at 1 right now. Let's run through our code. I'm just going to call it CZ just to make it simpler. CZ is at 1, right? For this value, we add 1, right? We're updating our max every single time, right? Therefore, our max is 2, right? So we got 1, 2, 3, 4 is our max, right? We get to the 1 here, and then we get to this next 0. Count 0 is at 2 now, right? So we're at 2, right? We're at this value. Right, okay, it's greater than 2. So like left is equal to right. So our left pointer is currently here, right? And our right is here. So then we do left is equal to right. So then our left is over here. And then our count goes back to 1, right? And then we keep looping. Well, we would check 1, and then we get 3. Then we get here again, right? Or right here. We'd make left here. Make it 1 again, right? And we count, but we get 4. But our expected is 3. How is our expected 3? Sorry, looking at 2. How's our expected 5? 10? Oh. I think it's because we're adding in that extra 0. That's why. Okay. For adding in that extra 0. We need to minus the left from it. The left value, right? So I guess, can we just do -1? There's no way this works, bro. Like, oh shit. Output 4, expected 5. Maybe is it left plus or equal to 1? Is that the right move? Well, instead of moving all the way to here, why don't we just go from here, but now we have an extra 0, right? So this if here, let's make this a while. While count zeros is greater than 1, we move. No way, I thought that was pretty close. We can get rid of the +1. That's what it's telling me. Never closed. Just do right minus left, because that gets rid of the +1. Right? There we go. That's cool. Nice. Okay. Take a look, let's refresh. Leetcode 75. 29 out of 75 through. Making progress. I'm gonna call out for today. My friend's actually here, so I'm gonna go hang out with him. I will see you guys tomorrow. Appreciate you guys watching.